Welcome student, welcome for this session. Okay. In the last session we have started with classical crypto system, which is chapter 3 of unit 1. Okay. In that we have learned a very basic encryption and decryption algorithm called as shift cipher or scissor cipher. Okay. So that falls under substitution cipher. Today we are going to learn more different substitution ciphers. Okay. Starting with vigenere cipher. Then we will learn what is Vernum cipher, okay, and then we will learn what is affine cipher, okay. Followed by them, we will learn what is cipher and ADF-GX, and the last one will be pseudo-random bit generator. So in this session, we are going to look at two ciphers which are almost similar to the shift cipher. We can say that both these ciphers are the variation of shift cipher, okay. The first cipher is vigenere cipher, and the second cipher is Vernum cipher. Now I have already solved the problem of vigenere cipher and Vernum cipher, as you can see on the screen. Okay, so we will try to differentiate how these algorithms are different from shift cipher and also from each other. Okay, to start with, we have already written the notation, because what we do in shift cipher is nothing but we just try to shift one alphabet with another alphabet. Okay, so what is very important in this is the key that we are using. So depending on the key, okay, we are going to do the substitution, just substitute one alphabet with another alphabet. Okay, so I have written the notation on the top. Okay, as you all can see, from A to Z, I have given the number from 0 to 25. Okay, so this is the notation that we will require in the problem. Okay, so let us start with vigenere cipher. Okay, vigenere cipher is a slight modification, okay, or it is a slight modification to the shift cipher. Okay, what do we do in shift cipher? We the formula remains the same. If we require a ciphertext, what is the formula for a ciphertext? It is plain text plus key. Okay, plain text plus key mod of 26. Okay, the same formula will be used in this vigenere cipher. Okay, but what is the variation? I will show you. And if you require a plain text, what we do? Ciphertext minus key. Okay, mod 26, we get the plain text. The same formula we will use for vigenere cipher, but what is the catch over here is the key. Okay, so let us jump directly to an example and learn what is your vigenere cipher. Okay, so the plain text that is given to you over here is nothing but she is listening. This is the plain text that is provided to you, and it is being told to you all to use vigenere cipher, okay, to find out what is the ciphertext. Okay, after that, that is nothing but the encryption part. Once the encryption is done, we will do again the decryption to check whether we are getting back our plain text or not. Okay, so the first step is to calculate what is our ciphertext. That is nothing but that process called as encryption. Okay, so what I will do first is nothing but, as I have told you, the formula remains the same. Ciphertext equals plain text plus key mod of 26. But what is the key over here? As I have told you, key is the catch over here. Key is nothing but set of numbers that are provided to you. So in this example, key is provided to you as 15, 0, 18, 2, 0, 11. Okay, so this is the set of the key that has been provided to you. Okay, so let's look now how your solution will look like. Okay, so what I have done is I have split the plain text, because as I have told to you, your plain text should be always written in the small lowercase letter. Okay, so I have split down my plain text over here into single alphabet. She, S-C-H-E, she is listening. Okay, what is my second step? I will just associate each of this letter with the notation that I have already given to you. Okay, so what does S stand for? S stands for 18. Okay, S stands for 18. Similarly, what does this H stands for? This H stands for 7. So I have just written it over here. So for each alphabet I have written the numerical notation that I have given over here, because whenever we are doing any XOR function, what do we require? Sorry, whenever we are doing any modulus function, what do we require? We cannot take alphabet, plain text plus key and do mod of 26. Okay, if at all we are taking alphabet, we have to take the ASCII value of the alphabet. All of you know each of the alphabet, that is either it may be a small case letter or uppercase letter, it has ASCII value. So basically when we do our modulus, we require a number. So that's why I convert my plain text into the notation I have given over here. Okay, now second is your key. Now in your previous example that you have done in shift cipher, key was constant. The value of key, if it is not given, was taken as 3. But here it is not the case. Key value, a set of key values has been given to you. So what we have to do is, we have to repeat these key values for the whole plain text. Okay, we have to repeat these key values for the whole plain text. What do you mean by this is, I will write down, for S my value will be 15. Okay, for H H my key will be 0. Okay. For E my key will be 18. Okay. For I my key will be 2. Okay. For S my key will be 0. For L my key will be 11. Okay. So now I have finished with my set of key. How many key were given to me? 1, 2, 3, 4, 5, 6. Okay. Where do I finish with it? Okay. I finish it at letter L. Okay. This letter I finish it. So what I will do now? I have to repeat it. Okay. So the same key I will repeat it again to the entire plain text. Okay. So again for I will give value as 15. For S I will give value as 0. For T I will give key as 18. For E I will give key as 2. For N I will give key as 0. And for I will give value as 11. Again I will finish with the second set of key. Okay. The same that I have repeated again I have finished with it. Still there are 2 alphabets that are remaining. Still there are 2 plain text characters that remain, that is N and G. So what I will do, I will repeat the key again. So what are the first 2 values of your key? Is nothing but 15 and 0 that I have also associated over here. So what is the catch in this algorithm? What is the catch in this encryption? Okay, how is different from your shift cipher is nothing but over shift cipher the key value is given as 3. Okay, and over here you have a set of key value that you have to repeat for the entire plain text. That is the only catch in this particular algorithm. Rest everything remains the same. What is the formula? Formula is nothing but, so now this is your plain text S, that is your character, first character. Your first character, I need to find out what is the cipher text for it. So what is the formula? Plain text is nothing but your cipher text is nothing but your plain text. Your plain text is nothing but S over here. What is the value of S associated over here is 18. So this is your plain text plus key. What is the key value that is associated over here is nothing but 15. The same value I have written here. Okay. So plain text plus key mod of 26. All of you know why we are doing mod of 26, because we are finding with respect to alphabet A to Z, which are 26 numbers. Okay. So mod of 26. So what is 18 plus 15 mod of 26 is nothing but 33 mod 26. Answer is 7. What is the letter associated with 7? What is the alphabet that is associated with 7? The alphabet that is associated with 7 is nothing but H. So for my plain text S, I have got cipher text as H. This is my cipher text. This is my plain text. Using the formula plain text plus key mod of 26. Same formula as we have used for our previous algorithm. Okay, that is your shift cipher. Now, what is the decryption? Let me check when I am getting the answer. Why I have written this H in capital? Because you, as always, I have told you the cipher text should be always written the uppercase letter. Okay. Now, decryption, what will be the formula for decryption as I have written over here? It is cipher text minus key mod of 26. Okay. So let us check now whether for this H I am getting back my plain text or not. Okay. So H is nothing but, so this is your this is your, now I need to find out what is your plain text. So this is nothing but your cipher text, that is value 7 that I have taken from here. Okay, minus cipher text minus key. What is the key associated? Key will remain the same, correct? Key will remain the same over here because it is the same level. What is the key associated with it is nothing but 15 mod of 26. What is 7 minus 15 mod of 26? Minus 8 mod of 26. Okay, the simplest way of calculating minus 8 mod of 26 is what? Just try to add 26 to 8. What answer you are getting is 18. Okay, so minus 8 mod of 26 is nothing but 18. What is the letter associated? What is the letter associated present over here at place of 18 is nothing but S. Okay, so I am getting my plain text back, right? So this is the plain text that I was searching for. Okay, so that means whatever encryption and decryption I have done is correct. Okay, so I will just repeat this. It's a very simple algorithm. It is a simple variation of your shift cipher. The formula remains the same. Cipher text is nothing but your plain text plus key mod of 26. What is the difference over here is nothing but there is no one key given to you. There will be a key, okay, a set of key that will be given to you that you have to repeat for the plain text. The moment you, now over here, the length of the key is nothing but 6 characters, 6 letters are given, 6 numbers are given to you. Okay, 6 key values are given to you. These key values you have to repeat. Okay, once they finish over the plain text. Now over here, see, for 6 letter we finish. So again, second set of key, same set we are repeating second time until you finish with your plain text. Okay. Then what you do? Okay. Then you just find out what is the plain text. Okay. Now plain text is nothing. Cipher text is nothing but plain text plus key mod of 26, and try to find out back the decryption part. So this is nothing but your encryption, what you have done. Okay, always write it when you are doing what is encryption, and this is your decryption. Okay, now the question can be asked in the exam is either to do encryption or decryption, or they might tell you to perform vigenere cipher on the particular plain text. So when it is given to perform vigenere cipher on the particular plain text, text and the key value, you have to do both encryption and decryption. Also very important part over here is you need to take care of the marks that are provided to you. If the problem is given to you for say if this text is given to you, she is listening, it's a very small text given to you to convert, okay, and if it contains, it is for 5 marks or 6 marks and it is not given whether you have to do encryption or decryption, you have to perform both. If it is for 2 marks or 3 marks, you have to perform the encryption, okay, and encryption, and similarly you have to write down for decryption the values will but it is always better to solve one encryption and decryption just to check whether we are getting our plain text back after doing decryption. So that is very, very important. Similarly, I want you all to tell me for the remaining letters. I have just solved for my plain text S. Okay, so the remaining letter is H, E, I, S, L, I, S, T, E, N, I, N, G. So you need to tell me what is the cipher text. I am not telling you to again do the decryption part. I am telling you only to do the encryption part. Okay, so solve and let me know what is the encryption value. Okay, what is the value of encryption for the remaining text. Okay, we have already calculated for 1. Okay, we have already calculated for H. Okay, S, that is nothing but we are getting the cipher text for S as H. Okay, so now I will give you time to solve. So before that, what we can do is in the last example shift cipher, I remember I had asked Darren, okay, what is the major drawback of this algorithm? How a crypt analyst can easily find out the key, and in turn he will find out what is the plain text. Okay, that was nothing but because the key value was 1, single value was taken, lot of alphabets were repeated. Like for example, if we have S, okay, if S is repeated 4 times in the particular text that we are transferring, the value of the cipher text will remain same for it. So that is why it is that particular drawback which was there in your shift cipher, okay, is taken care over here in your vigenere cipher. Okay, so that is most important part. So what you will do is you will just find out what is the value. Okay, you will just find out what is the value that is associated with the remaining text. Okay, then we will continue with our next cipher. Okay, so the next cipher, as we have discussed, our previous cipher was vigenere cipher. Our next cipher is nothing but as Vernum cipher, or it is called as one-time paired. All of you heard about the OTP. Okay, now this is a very basic version of OTP algorithm. There are a lot of revisions that have been made for this OTP. So let us learn how does this OTP algorithm works. Okay, basically it works on the similar line how we have worked for vigenere cipher and how we have worked for shift cipher, but over here the formula changes. Okay, so the formula for calculating the cipher text in your Vernum cipher is nothing but it is key plus the message mod 26. Okay, or usually what was the encryption algorithm that we have used for vigenere and shift cipher is nothing but it was the plain text. This message is nothing but a plain text. Okay, this message is nothing but a plain text. So plain text plus key mod of 26. It will not affect when we are doing the calculating the cipher text. What is the formula for decryption over here? When I need to calculate what is my plain text, it is cipher text minus key mod of 26. Okay, so it is cipher text minus key mod of 26. So please keep this formula into mind. So when we are calculating the cipher text, it is key plus plain text. Okay, when we are calculating the plain text back, that is nothing but decryption, we use cipher text minus key mod of 26. So using this formula, you have to solve what is your Vernum cipher, or it is called as one-time. So you don't need to get confused, just keep the formulas in mind. Okay, so directly we will jump to an example. The plain text that is provided to you is nothing but hello. And what is the difference over Vernum, vigenere cipher and Vernum cipher? The key here will be provided to you in the form of alphabets. Nothing to worry. What we have to do ultimately when we are doing our modulus, we have to calculate the key, okay, in terms of our associated number. Okay, so the key will be provided to you in the form of letter. Okay, so I have taken the plain text over here. So my plain text is HELLO. So as my first step, as I have done in vigenere cipher, what I will do, I will associate my plain text with the number as on top. So all of you know H is 7. Okay, you can just see on top what I have written. E is 4. Okay, E is nothing but this 4. So that I have taken over here. Similarly, L value is 11. Okay, so L value here is nothing but 11. Okay, similarly one more L is there, 11, and O is nothing but your 14. Okay, O is nothing but your 14. So I have taken the values. Okay, so what I will do now, I will write the key. What is the key? Key is XMCKL. Okay, again is the value associated with this X. What is the value that is associated with X? X is nothing but this 23. Okay, so I have taken this 23. Similarly, all the values. M is associated with 12. Okay, M is associated with 12. Then your C is associated with 2. Okay, okay, C is associated with 2, okay, K is associated with 10, okay, K is associated with 10, okay, K is associated with 10, okay, and your L is associated with 11, KL, okay. Now, what is the difference? Now the question that might arise is, over here, plain text is hello, okay, HELLO. How many letters are there? 5 letters are there. Key is what? XMCKL. In our previous method, what we have done, we have repeated the key, okay, the key which was given to us, we have repeated this key again and again, okay, once until the plain text finishes. Over here, what will happen is, we are not going to repeat the key, okay, your key will be of the length, okay, your key will be of the length equal to, so the length of the key will be equal to your length of the plain text. Okay, so this is the catch in this algorithm. Your length of the key will be equal to the length of the plain text. So now you can see if the text is, if your plain text is of 100 characters, your key will also be of 100 characters. In this example, I have taken only 5 character HELLO. Okay, so if your plain text is of 100 characters, your key will also be of 100 characters. Okay, so keep that in mind. That is the difference between your vigenere cipher and one-time pad. Now did you understand why it is called as one-time pad? For every plain text, there will be a separate key. Okay, for every plain text there will be separate key. Now tomorrow if I take a plain text as cat, I will have a separate key, maybe say A, X, B, whatever it is. How do we generate this key? That is a problem, right? You might get a question that now if the text is of 200 characters, how do we generate this? Okay, now you need to generate some random keys, right? It is a random number. This key is nothing but what is given over here is a random key. How do you generate that? For that, we are going to learn pseudo-random bit generator. Okay, pseudo-random bit generator is an example, okay, where you can generate any numbers, okay, any random numbers of any length, okay, that is required to you. So it will generate continuously. So now you associate your key, one-time key that you get, okay, one-time OTP that you get. So every time what OTP did you get? Every time you get a different OTP. Why? Because for every plain text, for every message, there will be a different key that will be given to you. How this key generated? It is a pseudo-random bit generator. Okay, pseudo-randomly, okay, it will generate. There are so many algorithms. We are going to learn 2 algorithms in pseudo-random bit generator, which will generate this key. Okay, is it clear to all of you now? Your length of the key will equal to the length of the plain text. So let us come back to the problem. So we have written the plain text. We have written key. What is our formula now? Key plus plain text mod 26 to get our cipher text. So this is my encryption formula. I will just write down. This is my encryption formula. Always you have to write down what is encryption, what is decryption. Do not get confused. Okay, it should be clear in the paper whenever you are writing what is your encryption and what is your decryption. So I will do for one letter. Okay, I will do for one character. You have to tell me what is the answer for ELLO. What will be the cipher text for ELLO? Okay, so encryption part is nothing but I have taken the first character H. Okay, what is my formula? Key plus plain text. What is the key that is associated with this L is nothing but 23. The same key I have taken over here, whatever is associated, plus key, okay, plus your plain text, that is nothing but message, H. H is what? According to the alphabet that is written over here, H is nothing but 7, correct? So 7 is the value associated with H. So 23 plus 7 mod of 26. What is 23 plus 7? 23 plus 7 is nothing but 30 mod of 26. What is 30 mod of 26? Okay, 30 divided by 26, your remainder will be equal to 4. What is present at location 4? We have the letter E. But while writing in the cipher text, how do I write? I write this letter in the uppercase letter. Okay, so for my plain text small h, I have got a cipher text as capital E. Okay, now remaining you have to do, I will just do one more decryption part for it. Check whether we are getting our plain text back or not. Now what is the formula for decryption? It is cipher text minus key. Okay, now what is the cipher text that we have got over here is 4. So it is cipher text minus the key will remain the same. Okay, whatever key we have taken, whatever key was associated, the same key is taken over here. So it is 4 minus 23 mod of 26. So what is 4 minus 23? It is minus 19 mod of 26. What is minus 19? I have not written over here. It is minus 19 mod of 26. Okay. So what is minus 19 mod of 26? The simplest way is to add 26 to it. So answer is 7. What is present at location number 7? Okay. The 7 is nothing but your H. Okay. 7 is nothing but your H. So we guarantee that whatever plain text we have written, okay, the same plain text we get after our decryption algorithm. That means the algorithm is correct and you have correctly solved the problem. Okay. So now similarly you have to solve for your letter E, okay, letter L, again letter L. Okay, now here see, here you cannot do like what you have done for your shift cipher. Okay, that I have calculated one L, so my second L value also will remain the same. No, because this time your cipher text, your key value is changed. Okay, for first L the key value is 2, for the second L the key value is 10. So you cannot say that your L value, both the cipher text value for L will remain the same as in the shift cipher. That was a disadvantage of shift cipher. That's why we had solved vigenere cipher when there is continuation of the key. Okay, the more robust algorithm is nothing but your one-time pad where we are generating the length of the plain text will be equal to the length of the key. Okay, and the key will be different for each plain text. Okay, so that's why you need to solve and tell me what is the plain cipher text for E, L, L, O. Okay, and then verify by doing decryption whether you are getting back the plain text or not. Okay, so we will do, that's all that we are going to do in this class. Okay, I will tell you the answers of this algorithm. Also I will give few more examples for calculations. Okay, few more examples for your homework. But I will like to tell you that usually this vigenere cipher, Vernum cipher are not asked in your semester paper. Only one paper I have seen where your one-time period was asked. Okay, your Vernum cipher was asked to you all. So you need to know the basic idea. Okay, you need to know how does this vigenere cipher work, how does this Vernum cipher works, because they are the basic cipher in classical crypto system. They are the basic cipher in your substitution cipher. So as of now we have learned what is shift cipher, what is vigenere cipher, and what is Vernum cipher. In the next session, okay, so you need to solve this problem. After that, in the next session we are going to do what is a affine cipher, which is also a type of a substitution cipher. Okay, thank you.